Hello everyone, my name is Albert DAYOR PIERSSON, and the co-authors on this study are the same as my co-supervisors. The title of this study is Multi-Kernel Machine Learning-Based Multistructural MRI Classification of Alzheimer's Disease and Healthy Control. What is Alzheimer's disease? Alzheimer's is the most common form of dementia, and it takes about 60 to 70% of dementia cases. According to the World Health Organization, 60% dementia cases live in low and middle income countries. It is a disease which is neurodegenerative in concept, and it is most often associated with memory deficits and cognitive decline. Currently, there is no cure, and so early diagnosis remains key to quickly tackle the onset of this disease. Looking at the brain of normal person and the one without Alzheimer's disease, you realize that the normal brain, the folds of the brain are clearly intact compared to one with Alzheimer's disease, where you have some gapings within the folds of the brain, and then you have structures of the brain which are kind of sunken. So eventually there is a reduction in the brain volume, as you can see this. So this disease called Alzheimer's is mostly ravaged by two major proteins: amyloid plaques and then neurofibrillary tangles. The amyloid plaques themselves tend to propagate from the isocortex of the basal cortex, where they then move gradually to affect other associated regions, and then they engulf the entire region of the isocortex, which also includes the sensory and the motor core fields. The neurofibrillary tangles, which are also protein-based, tend to also have a different pattern compared to that of the amyloid plaques. In this case, they start from the transentorhinal region of the brain, where they then tend to propagate along this region deeper to affect the other layers of the entorhinal and then the transentorhinal layer. And then in the severe stage, they move on to the isocortical region. So these plaques can propagate in various forms. For instance, you have the pretangles, the mature tangles, and the extracellular ghost tangles, which tend to propagate along these structures of the brain. So what is the focus of our study? The study intended to assess the capability of multi-kernel learning machine in differentiating patients with Alzheimer's disease from those with healthy cognitive status, and then to determine whether combined feature sets could provide a more improved classification accuracy. So here, our patients went through the routine medical and neuropsychological assessments where depression and other dementia were excluded. Then they went through neuroimaging, where they specifically did MRI study. So we recruited 10 patients with Alzheimer's disease and then 14 healthy control subjects. So they are quite elderly, and they all went through three major cognitive assessment tools: the mini mental state examination, clinical dementia rating, and then MOCA, which is a Montreal cognitive assessment. So our patients went through the images we acquired from them. We subjected them through segmentation, where we extracted the gray matter, the Jacobian scaled gray matter, and then the white matter from the whole brain. So we fed the data through a machine learning system, where we applied a whole brain mask just to block out every other external influence that may affect the reading of the brain. So we extracted the features from the gray matter, Jacobian, and then the white matter. We put in a cross validation of 5, and then we use a multi-kernel learning machine, and then we optimize the upper parameter. Then we estimated the model, where we were able to generate 4D weighted images. And then we applied permutation so that we could know which of the regions showed statistical significance. So here we are. We found out that the classification accuracy of gray matter, which you can see here, which shows 95%, which is statistically significant, and then the Jacobian are the same, which is also the same as when the three feature sets were combined together. So All these ones show statistical significance when we classified both the AD and then the healthy control subjects. Then we went on to find out which of the regions of the brain contributed mostly to this disease, at least something to tell us that, okay, the structures that contribute to the brain, the disease of patients with Alzheimer's disease are also the same regions that manifest in neuropathological assessments. So we found out that the gray matter showed that the right hippocampus contributed most significantly to the disease, whereas the white matter showed the left hippocampus. The Jacobian also showed right caudate, and the combination of the three also showed the right hippocampus. So, in conclusion, our study shows that the multi-kernel machine is able to differentiate patients with AD from healthy cognitive subjects. Further, the gray matter hippocampus, which is highly implicated in the Alzheimer's disease neuropathological process, may provide a better overall performance for the classification of Alzheimer's disease and healthy control. Thank you.